Hello again. Today I wanted to continue with the solution or a possible solution of this problem of interference between the corridors we do between levels and the new exits we find. So the exits don't interfere with the entrances or so forth. Okay, we are doing the pathfinding and the deformation of the pathfinding randomly in this function. But we must separate, we must construct the moats around the entrances and exits of the levels during the pathfinding and remove them after. So we will separate the actual making of the path let's make a new function that receives, let's see, this should receive receive the level okay, and yeah, this is this should not return anything because we are returning from here the path. Return empty. And here we return the path. Okay, so let's see if let's make path. This receives the path and the level 1. Okay, this refactor should leave everything as it is. Okay, now before making the path and sorry, after let's see, no, before let's rename this function. Because it doesn't draw. Before we calculate the path, we must put the moat. So let me see. We need to use use these directions, which are the 8 neighboring directions. Let me check on my cut. Okay, for each one, let's call it vir. Let's use the beginning. Oh no, we must do this for each, let's see, let's see. What? Sorry, my cat is asking for attention. Okay, for each pedestal in the second level, we must add a moat. So we will compute the neighboring positions in based on the let's see. We compute the position of the pattern, yeah. And this is a local position, so we need to add the global position of the level. Let's see. Why? Why this? No. What is? This is a three-dimensional position. Okay. Let's construct. Yeah, let's first construct the global position, and then construct it's a bit doesn't have set a type. What? Why not? This is okay. Yeah, the types the types in Godot are a bit or the type inference. It's a bit wonky because this has the type here. This is, yeah. Yeah, because that array is used in the thing add function that receives node 3D. This is what happened. Okay, never mind. Let's see. Now, obviously, now the path is not using these 3 points and is not putting walls, a wall here, but we wanted to put the wall. So the problem is that, let me see. Okay. We are adding these solid points. We calculate the path, and if it's not empty, we remove the solid point. Okay, now the function make path made the necessary walls. So when we solve for this position, we should not fall. Perfect. Okay. Now, the problem with this is, let me see, this was part of the, this is interesting. This was part of the, what happens if we don't connect the levels? Let me see. If we do this, okay, this these three are free, and there are no walls here. What happens if I solve again for this solution? Obviously we fall, but this is a bit weird, because these walls that we are adding here are not part of this level. They are this is very strange. When we call this, we calculate the path, and we make the path for the level 1. Oh, this is weird. Never mind. I'm obviously these walls are part of this level because they are part of this corridor. I was not seeing. Okay. Now, now I understand better. Okay. Now, the problem is that we have the same problem as before, but now with itself, with the same, within the same level. So it's not enough to make the moat around the level 2, the second level we are connecting. Like in this case, we made this moat, and that allowed for the construction, for the correct construction of this corridor. But in this case, we also blocked this problem here, but we did not block this problem. So we need to we need to do this. Let me see. Pen. How do we? If we do this, what happens? Can we? Can we append two arrays? Operator plus concatenates two arrays together. with the right array being added to the end of the array specified on the left operand. But does this changes the first array? Let's try it in the ready. Let's print a plus b and a and b. Nice. It doesn't change the original arrays. Okay. Okay, we are so in this case is protected this is good because we are using we are using the pedestals. Is the same? Is this the same? Let's see. Let's check. If we do as before, we make the same corridor for the first case, but if we do this, this picks a random pedestal. In this case, it will pick the only pedestal, which is this one. And I wonder if we are wonder if we need a parenthesis here. The beginning is the position of the pedestal. This is incorrect because we are we are adding the incorrect global positioning. Okay, we need to do this twice. One for the Okay, we need to do this. I wonder if we need to factor this into a function. For now, let's duplicate the code. Level 1. And this is correct. Okay. First, we do it for the first level with the first global position, and then for the second. Now, obviously, this will not work because we are covering the very pedestal we are intending to connect. So, in the first one, we must check we continue. If we check the randomly picked pedestal, we continue. Okay, now the problem is, I think this is correct. Let's see. We have no problem here. We have no problem here. Perfect. Nice. Now, there could be problems with other levels if, for example, if there is just here a level, it could interfere with this path. If we have a pedestal, an exit pedestal for a level here, it could interfere with this. So obviously we need to add another okay, but this is done. We will move it here, and for now I think I will end here because this worked. So for now the local solution is correct. We avoid blocking or interfering with future exits. So the task is done. Thanks for watching. Please press like if you like the video and share it with people that could enjoy this kind of content or perhaps could learn something from it or what. Thanks.